Let's say a few things about what the accumulation function in general does. This is, remember, our formula for the accumulation function. And if we have a generic graph like this, the accumulation function is the integral from a to x of f of t dt. And it tells us, for a positive function anyway, how much area has accumulated from a out to x. Let's make a few notes about what's going on here. The first thing that we can note is that if we plug in a to the accumulation function, well, that means that we take that a right there, and we put it in for x. So that becomes the integral from a to a of f of t dt. And the integral from a to a of f of t dt, well, there's no width there. If we go from a to a minus a is 0. So it's a 0 width height, or 0 width, and whatever the height is doesn't matter. So this is going to be 0. So the accumulation function at a is equal to 0. The second thing is that if the function's positive, like it is in this graph, and we have the x bigger than a, then a of x turns out to be bigger than 0. And it is exactly what we said earlier. It's the amount of area that's accumulated from a to x. So in this case, a of x is just equal to this area, a1. But if x is on the other side of a, if x is over here, then things change a little bit. So if f of x is still greater than 0, and x is less than a, if x is on the other side, then the accumulation function is negative. So if we integrate from a to x and x is less than a, the amount that's accumulated is negative, essentially because we still take x minus a, and now x minus a is going to be negative. So in this case, a of x is minus this area, minus a2. This is a positive area, but the accumulation function for x less than a, even if that's positive, is going to become negative. Those are some general remarks about the accumulation function and how it behaves.